Alright, so 1.6 relations. We have new vocabulary. Alright, so we're going to make a table, graph, and map our points out. Remember that your x-coordinate is the first one, and then the y, they're in alphabetical order. We're going to list the table. So we're going to do the x-coordinates in the first column and the y-coordinates in the second column. So when we graph it, we have all of our x-coordinates, so 4, -2, 2, 0, and then our y-coordinates on the other side. Graphing, we're going to graph all of our points so that we have our x-coordinates along the x-axis and the y-coordinate along the y-axis. So we have this point here is we have 1, 2, 3, 4, so we have -4, 0, 2, -4, or I'm sorry, this is 0, 0, -4, 2, -4, -2, -1, and then this coordinate is 4, 4, 4, 3. Questions on that? Are we okay with graphing? Alright, the last thing is mapping. I'm talking. Alright, so here we're going to map. So this is, the domain is our x-coordinates, and the range is our y-coordinates. So we have our x-coordinates here, so we have 4, 3, and then we have -2, 1, and we have the red lines showing what goes together. The benefit of this is if you have multiple, a couple different points of your x that map to the same value in y, you don't have to write it twice. Alright, so now we're going to determine the domain and range for the relation. The domain, if you look back at the last one that we just did, our x-coordinates are our domain. So when we're looking at our list to determine the domain, you're going to look at your y-coordinate, your x-coordinates, and for the range, you're going to look at your y-coordinates. So looking at our list here, we want to write the range. We have just a series of points. We are not connecting them with a line of any sort, so we're just going to list them out. It's a discrete data. It's just these points. So if we're looking at the domain, what's the list of our x-coordinates? Starting with the smallest and going towards the largest. So what's our smallest x value? -2. Alright, so this is our domain. And then looking at our range.
-4. -4, -4, -1.
Actually, wait.
Alright, so
-4, -1, and then 2.
3.
3.
Well,
right, we don't need to list it twice. So because we have 2 -4s, we just have to list it once. And this is our range. So good job. Yes, Anthony? Alright. They went from greatest to least. Alright. So expressing the relation. So which of these is expressing this relation in mapping form? Well, what can we eliminate right away because it's not mapping? We can eliminate B and mapping. So A and B. So we have mapping is here. So which one can we eliminate? So we have, what's the difference between the two? Alright, so why can we eliminate C? Because you're correct.
Because when I was looking at the top part with isn't negative 2 the
Oh wait, hold on.
That'll be
because in the x column there's no negative 2 for the first value.
All right, so on here, on our list, what goes in the domain? Is it our x or y coordinate?
X.
X. So our x coordinates are 3, 4, 5, and -1. So which one has those in the x?
C.
C. And then our y coordinates are -2, 6, 2, and 4. So which has those values in the domain? C. And that's what you said, right? So C is correct. All right, so looking at this, determine the domain and range of the relation. All right, so the domain is all of the which coordinates? All the x ones. So which are our x coordinates?
First one.
The first one. So we have 3, 4, 5, and -1. So which, what can we eliminate just because it doesn't have the x coordinates in the domain?
Well, B.
B. What do they have in the domain? What?
-2.
They have -2, 2, 3, and 6.
And there's
2 is a y.
Right, so these are our range values, so we can eliminate B. What else can we eliminate?
C and B.
C and D, because those just have partial.
And now has 1.
Alright, so A has all of the domain and all of the range. Alright, so example 2, so we're going to look at independent and dependent variables. So in warm climates, the average amount of electricity used rises as the daily average temperature increases and falls as the daily average temperature decreases. Identify the independent and dependent variables for this function. Alright, so we're looking at, what are the two things that we're looking at? That it's asking us to compare.
Average temperature increases and the daily average increases.
Alright, so we're looking at the daily average temperature, and what else? What are we comparing it to?
The fall and the daily temperature.
We're looking for the average amount of electricity. So identify the independent and dependent variables for this function. So now let's think about this. So what the independent variable is what goes into the equation. It's what's determining the outcome. The dependent is the outcome. So in a typical XY equation, so if we have y equals 3x plus 5, x is in the equation. So whatever value we put in for x, that's your independent variable. And what we get out, the y, whatever number that is, that's your dependent variable. Right? Because it's changing depending on what's happening inside. So if we think about this, what's going into, what's determining the outcome? So does the average amount of electricity, is that going into the equation and affecting how much, what the daily average temperature is? Or is the daily average temperature impacting the amount of electricity people use? So if we look at it this way, if it's cold outside, what happens in your house?
It's warm.
And how do you heat the house? Using
Electricity.
So in that case, is the electricity controlling the temperature, or is the temperature controlling the electricity?
The electricity is controlling the temperature.
So if I turn the thermostat up, is it going to get hot outside?
No. It's going to stay the same.
So the temperature is going to be what it is regardless, right? So if it's cold outside, I turn the heater on, and that's going to increase my electricity, right?
Yeah.
But if it's nice outside, am I going to turn the heater on? No, so I'm going to use less electricity because, like a day like today, I'm not going to have the air conditioner or the heat on. So my electricity usage is reduced. So what's impacting what? Is you turning the heat on impacting the weather, or is the weather impacting whether you turn the air conditioner or heat on?
The weather is impacting the
Okay, so in that, what's the independent? What's controlling the outcome? Is the weather controlling?
The weather's controlling the outcome.
So weather, is it independent or dependent?
Independent.
Independent, because it's doing the controlling, and dependent would be your electricity because it's what's being controlled.
Yeah.
Alright, so a non-math example of independent and dependent is if a person is independent of anybody else, then they don't rely on anybody else for support. So they have a job, some sort of income where they can buy their own food and clothing and whatnot. So like a typical responsible adult. So most of your parents are independent adults. They have some sort of job that takes care of the basic necessities, right? You are what the government calls their dependent. And you are dependent on them to take care of you, right? To buy clothes and food and have a house, right? So in that case, your parents probably control some of the things that you do, right? They can control, whether you have a car or not. I don't know. What else do they control? Right. Because if you move out, you can become independent, but then you have to take care of yourself. So when you're independent, you do the controlling. If you're dependent, someone's controlling you. So in algebra, what's in the equation is independent, and what comes out of the equation is being controlled by what's going on inside.
Yeah.
Okay.
Bus.
Alright, so the number of calories you burn increases as the number of minutes that you walk increases. Identify the independent and dependent variables of the function. So, what are the two things that we're looking at? Alright, so we're looking at the calories you burn and minutes that you walk. So we can look at it in two ways. The number of calories that you burn determines how many minutes that you walk, or the number of minutes that you walk impacts the calories you burn.
Minutes that you walk.
Right. And when you go for a walk, if you're exercising, you do it for a certain time. You don't sit and say, I'm going to burn this many calories, because it's kind of hard to do, because everybody's different. All right. So the time is the independent variable. The number of calories burnt is the dependent variable, as it's affected by time. All right. So let's do this one. All right, so now let's look at example 3. The graph represents the temperature at Miss Lang's classroom on a winter school day. Describe what is happening in the graph. All right, so here the temperature, it's increasing and decreasing, increasing, decreasing. So what's a scenario that could be happening in that graph for the increase and then the decrease, but only to a certain point. And then it warms back up, cools back down, warms back up, cools back down. It's in the winter, right? So what do you think this period where it's warming up, what's happening, what's kicked on in the classroom? The heater. So the heater kicks on until it reaches a certain point, and then it turns back off. The temperature cools back down, then the heater turns back on. And then what about here? What's happening at this point?
The heater's off.